Hi, my name is Nico. I've been in project management for over 30 years, and in this video, I explain how to set up a survey and how to analyze the information from that survey. In my line of work and over the decades, I had to deal with a lot of surveys related to health, sanitation, agricultural and water projects. A well-designed survey will give you a lot of useful information and tells you on how to proceed further. On the other hand, a survey that has not been properly set up will give you headaches further down the road. So how to begin? Well, first you have to know what the needs are. You probably have an idea based on those needs and a general idea on how to tackle these. It could be anything from an idea for a new toy you want to sell, to supplying water to a community in a drought-stricken area. Whatever it is, you will need information, but how to gather useful information is the tricky bit. In this video I use a fictional example of an organization that plans to improve hygiene practices in a region known for its waterborne diseases, and the aim is to reduce these preventable diseases. Medical reports indicate larger than usual incidences of diseases like diarrhea, typhoid and other related illnesses from the area. However, little is known on availability and use of water, nor where people get their water from. There is no information on hygiene practices in use by the community, like how often people wash their hands, what their toilet facilities are. You do know that the average household size is 5 persons and the population size of the area is around 50,000 people. That it is a rural community with subsistence farming, that there is no network coverage, let alone internet. But that is all the information you have, and that is not enough to make a plan. First and foremost, in this context, talk to the authorities and the community leaders, explain your plans and get their approval. If you don't get that, there is no point in continuing. And if you do go into a rural community asking questions out of the blue, you will get into serious trouble. Start by writing down what you need to know to achieve your goals, nothing more and certainly nothing less. In this case, you probably want to know the following. Where do you collect water? Indicator is the maximum distance in meters from household to potable water collection point, which is less than 200 meters. Where do you go to defecate? Indicator is percentage of households reporting defecating in a toilet, which is greater than 85%. Number of persons per toilet or latrine should be less than 20 persons per facility. Where do you go to bathe? Number of persons per bath, shelter or shower should be less than 20. Does the household have access to soap? Percentage of households with access to soap should be more than 90%. Normally the number questions with this type of survey are much larger than I write down here, but for the sake of clarity, I kept it short. Since you are going to interview households and you know that the average household is 5 persons and you know that the total population of the area is 50,000 people, then it is not practical to interview 10,000 households, so you are going to have to do sampling. But how big does the sample size have to be for the survey to be valid? 100 households, 1,000? Statistics can help you with that question. Determine your confidence level, set this to 95% or 0.95, in this case set the Z-score to 1.96. Specify your standard deviation, set this to 50% or 0.5. Set the margin of error to 5% or 0.05. The population size to 10,000. Then your sample size should be 370 households. Now that you have your sample size, you are almost ready to begin your survey. But you don't want to interview 370 households from one village. If you do, your data will not be accurate. It is important to spread out your teams geographically over your target area. It has to be an area with at least 30 households. There is no point sending a team to a desert with no people. For the sake of accuracy, each surveyor should interview at least 30 households in one survey, can be more but not less. This number 30 comes from the central limit theorem and it increases the confidence level. Now let us say that you send 5 surveyors out over the area and that each surveyor can do or supervise 74 interviews. Then if all goes well, they could complete the job in about a month. Prepare your questionnaire with care. It is wise to do a trial test with a limited amount of people, for example your staff, who can give valuable feedback. Make sure your surveyors know the language and the culture of your population very well. For example, if you do a survey in some areas of Lisbon, people often use the word mole for money. If you do the same survey in Rio de Janeiro, the word mole means a spring. And yet they all speak Portuguese. Okay, now your team is back and they hand you a huge amount of data. How are you going to make sense out of all that information? Start by taking the average data of each surveyor and put these together in a table. You'll see immediately that surveyor Jim's data from Area 1 has some unusual numbers and differs a lot from the other surveyors. There where Jim could have filled out the maximum number of households, which is 74, he filled out 200. All his other data does not correspond with the information from the other surveyors as well. This should give you a good reason to be suspicious and have a chat with Jim. Over the decades, I've seen surveyors filling out questionnaires themselves at home or in a bar. This happened in ancient times and continues in this day and age. There are techniques to reduce cheating by using a combination of organization and statistics. You can and have to exclude Jim's data. But not all is lost, you still have some good data points. But what to do with that? You have taken the average of each surveyor and put these together in a table. With other types of surveys, you want to know how valid the data is. In other words, how reliable is the data in relation to the data from the other surveyors? You can use the null hypothesis test and the ANOVA analysis for that. But more often than not, you can tell by reading your table if your data is consistent, and, in this case, you can see that Jim's data is useless at a glance. Where people get their water from can vary wildly as well, so even if this data does not seem right, it could still be correct. You have received the indicators from the medical community and now you have your information. Just compare the indicators with your data points and you'll see which areas need improvement. With that, you can now make a plan to reduce waterborne diseases. There is a lot more to it when it comes to conduct a survey, but now at least you know how to start. Take care of yourselves and each other. Goodbye.